At this point in the series, you likely have a good idea of what AWS is, which is exactly the reason why I chose this to be the next topic. Is Amazon Web Services secure? Right? Because if you've got this big old shared environment, you might be thinking, okay, is there a chance that my competitor, my organization's biggest competitor, is running out of the same data center as me? Well, as a matter of fact, let's even go further. Is there a chance that they're even running on the same physical server as me? And the answer to that is yes, there is a chance that they are. So how do you make sure that that's secure? Well, the first thing we have to do is when you say secure, it's very obfuscated or ambiguous. That's the word I'm looking for. So it's very ambiguous. We have to define, what does that mean? I'm not doing this like a politician. Well, depends what you mean by tax break. I'm saying, let's just make sure we're all on the same page with what secure means. Second statement is, I'll jump if you do. This is a shared responsibility environment. Amazon is coming in and saying, hey, we've done our part to secure the environment, but you need to do yours. If you don't do yours, then we can't ensure that your environment is protected. So we'll look at what shared responsibility means and what Amazon Web Services has done to implement security and give you the tools that you need to practice security in your cloud environment. A couple of years ago, I got new windows in our house. Now, I'm out in Arizona where it is summertime right now, and the temperature, it's mid-June, and the temperature today is planning to get up to 112 degrees. It's insane. So we get windows that are super energy conserving. And so this window company came to my house, and they were trying to sell us these windows, which they did successfully. And they said these windows are super secure. They've got these double latch, like nobody's opening this window. And I was like, oh wow, it's secure, it's secure. So I'm thinking because he was also talking about how they're filled with halogen, and it's a window. Come on, but he's so my mind, I'm like, are they really that secure? I said, so what if somebody throws a rock at it? Can they get in? Is there some kind of bars? And he goes, well, if they break the window, they break the window. And so I was like, oh, okay. It's just a totally different perspective on security. He was like, oh, well, nobody's opening it with a latch, but if they throw a rock at it, oh, well, now you're in a totally different ball game, right? We're talking different levels of security. So we have to define, what do we mean when we say secure, as opposed to, in a compliance with Amazon Web Services. Well, what I mean is, number one, physical. Amazon Web Services uses mysterious locations. That's the best word I could think of there. As in, you're not going to figure out where their data centers are. And even if you do, the physical access to them is controlled. And you can go on their website and read about it. It's typical data center security, to where there's two-factor authentication, where, maybe like a retinal scan and a thumbprint. There's the, I can't even think about it, like the tubes that you walk in, where I don't know if you've ever been to a data center before, but it's pretty cool. It's like, Tom Cruise, Mission Impossible, lasers, and all. So anyway, they're saying physical access is tightly controlled. There are two phases of authentication that somebody has to go through before they're given access to the floor of the building. They have standard data center security. That's multi-factor authentication. That's what I was just talking about. So maybe one's a retinal scan, one's a voice imprint, or one's a thumb imprint. I know at the data center I'm at, as you walk in, it does a retinal scan, a thumb scan, a badge scan, and the tube that you walk in. Why can't I remember what they're called? So half the tube enters and then the other half enters, and so it actually weighs you. Once it figures out who you are based on your retinal scan, it says, okay, what do you weigh, to make sure that no one else is sitting in that tube with you. They have the same thing. They log every access in there, so they know who's in there, what they did, video surveillance. So all of that is typical data center security. Now the servers themselves are, and this kind of sounds like it's not even a security thing, but it is. So they use methodical management methods of their servers and of their physical infrastructure, the network infrastructure inside of there, to regularly rotate and change out the devices according to best practice standards. So that I'm not getting a server that's 10 years old. I ended up on the Sputnik server or something. So they're regularly doing that, because security also means ensuring that the components components of the network are regularly rotated so they don't fail. There's a mean time between failure on your devices for a reason. The storage itself, the hard drives, are decommissioned securely, meaning they're not only formatted and wiped, but they're physically destroyed. Have you ever seen those hard drive crunchers where they're like, and it's pretty vicious and fun to watch. If you ever go on Google Video and type in hard drive destruction, you get all kinds of fun stuff. And always on monitoring systems, to where they are monitoring every aspect of their facility, so they not only know about unauthorized personnel, but they know about everything else. Now this could go on and on and on. I just was giving you some big examples, but I would suggest if you're really interested in this, I put these logos because they have achieved just about every, HIPAA compliance, ISO compliance, FIPS compliance. So outside auditors have come into each one of these data centers and said, let me run you through what Department of Defense standards require for security. So what I'm giving you right here is just the tip of the iceberg on what has been audited. And if you talk to your sales rep with Amazon Web Services, they can even make any one of those reports available to you you have to sign a non-disclosure agreement, but they can make those available to you so that you can see for the data centers that you're running in what kind of certifications they have achieved. Okay, so a question for you. How many of you have heard of a demarc point or a demarcation point? Chances are you actually have one in your house or around your house. What it is it's where a point of responsibility passes. So let's say at your house you get a high-speed internet connection, right? So here's your home. What happens is the service provider, here's the street, they drive up, park right here, guy gets out, he trenches some cable, pulls out his shovel if it's not already done, trenches cable to your house, installs a little wall jack, and they say, well, they probably won't tell you this, but they say, okay, this is the point of demarc, where our responsibility, if something breaks, is actually over here. So we will come out, we will pay for it, we will fix it if something over here happens. But if something over here breaks, then it's your responsibility. And if we have to come out, we're going to charge you for it. Well, I should teach demarc in reality. If something over here breaks, they convince you that it's over here and they come out and charge you for it anyway. But that's supposed to be what the point of demarcation is. And Amazon Web Services, when they say shared responsibility, does the same thing. They're saying, okay, we will guarantee that our side is secure. So what do you mean by our side? Well, what I mean is, number one, they will ensure that virtual hosts are secure. They have all of, if you go into a rack of equipment, they have all of these different servers, many of them hosting multiple, 10, 20, 100, I don't know how many they provision their individual servers to run, virtual machines. And so those could be from all kinds of different companies. So, over here is Animoto's virtual machine running on there, and over here is you. Right? And what they're saying is we will ensure that Animoto can't get into your machine, and so much so that we will separate network traffic on there. So if you open up even a wire sniffer or anything like that, and Animoto's servers start sending broadcasts and whatever kinds of traffic, you will not see them. They completely separate the virtual host and all communication to them. The storage is secure. So you have the servers and they link to other storage, and we'll talk about storage. It might be elastic block store, it might be ephemeral storage, it might be S3 storage. So you've got all these little storage banks, and again, they're going to say, Animoto will not be able to jump into your S3 bucket and access your data that you've stored in there. We will ensure that is completely separate. If you run database services through us, we will separate those. Now I'm not talking about running your own database server. I'm talking about they will ensure that your database does not blend with anybody else's. Network security, I talked about that already. Your traffic will not blend with anybody else's, in the sense that they won't be able to see yours and you will not be able to see them. Data center security, that's what we just talked about, the physical security. People are not going to get into the AWS data center that are not authorized to do so. Most people don't even know where they are. Matter of fact, I was talking with some of the technical engineers at AWS, and they're like, we don't even know where they are. We haven't even been to one. So it tells you how far Amazon separates even technical engineers. I'm talking people on the phone helping you set up AWS if you're stuck, or supporting you. A lot of them haven't even been inside of an AWS data center. So that is what Amazon says is our responsibility. Now let's talk about you and I. Amazon Web Services has given us this slab of concrete, the foundation down here to build on of security. And what are we building? servers. Instances is what Amazon Web Services call it. So we can bring up, some Windows servers over here, some Linux servers over here. They're all virtual servers running in the cloud, and they are ours to play with. And Amazon says we will give you the ability, if you'd like, to expose them completely to the internet, as in no firewall whatsoever. Now, Amazon says we will even provide you some virtual firewalls that you can use, and they highly suggest that you use those security groups or access lists. We'll talk more about those later on. However, you don't have to. You can fully expose it. And let's just say this is Windows 2008 or 2012. That's running. If you expose that guy fully to the internet, not keeping up with the patches and so on, not to down Microsoft, but they will get destroyed. Somebody will find a backdoor into that server some way and compromise it and really destroy and cause havoc with your system. So this is where the shared responsibility comes in. They will give you the building blocks and ensure you that the building blocks aren't secured. Nobody's going to be able to come in from another virtual host without any firewall and take you out. They will ensure that, but that does not mean that somebody from the internet on your own doing, when I say your own doing, I mean you've configured the firewall to allow full access to the internet, not patched anything in the way it should be. Somebody could come in and compromise this. Now remember, Amazon Web Service builds a bubble around you. So you may get compromised, and then they can use that as a platform to jump off and start attacking all of your other machines. But Amazon Web, you may have like a full-fledged infection, but it will be contained. I don't know why I'm thinking of like a movie like Outbreak, where you have this virus that starts taking out North America or something. But it will be contained. Like your system will be destroyed, but it won't affect the other people that are running on that same physical server, because Amazon guarantees that you are completely isolated. So your responsibility is to secure that operating system, to keep up with the patches, to set up a firewall if that's what you are doing. Now you can set it up on, inside of Windows itself. Windows has a firewall, Linux has a firewall. Amazon Web Services also gives you firewall capabilities with storage groups, security groups, access control lists, and we'll talk about those later on, but you can also add a host firewall running on your operating system to that. You want to make sure your applications are secure. So for instance, if you're hosting a website on Apache or Internet Information Services, make sure that those web services are patched and kept up to date so that somebody can't get into the application itself and compromise you. They say data encryption is your responsibility, and it's funny because they're like, it's shared responsibility, but Amazon is like, here you go. It's like, here's your little toolkit, friend. We will give you every tool that you need to encrypt it, but we're not going to force you. You don't have to encrypt your data if you don't want to, but we're relying on you to do that, is what Amazon Web Services says to us. I can't believe I spelled that wrong. I just saw that. Authentication, making sure that you set secure usernames and passwords into the systems. Those are your responsibilities. Network integrity. Now, I'm not saying, this side of the network. I'm talking about when you're sending stuff to the internet, putting usernames and passwords in an email that comes out from the system is not secure, because emails typically, unless you configure them otherwise, are sent in clear text all around the world. So somebody could sniff that data and compromise it end to end, not within Amazon Web Services, but once it leaves out to the rest of the world. So you kind of get that feel. So we are responsible for securing what we build on that foundation. The point is we don't have to worry about the foundation cracking. We don't have to worry about, Nabisco and their Fig Newton Wonder coming in and trying to hack our server on the same virtual host, and they get around all the firewalls because they happen to be within the same physical host. Amazon guarantees and supports against that. Now, diving in depth into all the security methods that Amazon Web Services provides is not what I want to do here, but I do want to give you, think of this like a movie trailer, right? Like a sneak peek of what we are going to talk about and some of the tools that they give you at your disposal. First off is security groups. When you set up your instances, you can set up security groups which immediately put a bubble around there and say who is protected from getting inside of there. You can even set up multiple security groups and protect your own servers from your own servers. Maybe you've got a design. Let me clear this off and get some space. Here's the internet coming into your system. Maybe you have it set up to where you have some front-end servers right here that take the brunt of the internet traffic and have really high security, and those are put in their own security group. And then we say, okay, well, I've got some private, maybe database servers behind here that I'm going to say the only way that somebody's getting to one of those database servers is if they're coming from this security group and accessing this one over here. So you can kind of set up tiers of servers. So if if someone from the internet can't actually get directly to there. Virtual private cloud allows you complete control of your networking environment, whereas normally, I'll say by default, and even this is changing. Let me say, for now, when you spin up a instance, when you run a server in the cloud, it kind of goes into this big generic network land that you don't really have control of. It's just you get an IP address, that's all you care about, and you know that your server can get out to the internet. Well, virtual private cloud, which is now becoming the default, that's why I was like, in a lot of cases, gives you the control. It gives you the ability to provision your own IP subnets and network and all that. And as soon as you do that, you gain the functionality of access lists. Access lists allow you to protect not only who's coming in, but even who's going out. If and this is where I get to my love, networking. If you dealt with Cisco devices at any point, access lists gives you 100% control of exactly what IP addresses are allowed to go out, what IP addresses are allowed to go in, even what protocols, like protocols being like TCP, UDP, ICMP. I mean, we're getting into a lot of heavy networking stuff, but I can say, you know what, TCP, let's see if you guys know this one, TCP port 80. Anyone know what that is? HTTP. Right? That's the most well-known port number in the world. So I can say the only thing allowed in to my network is TCP port 80, and even, maybe this server out only has the ability to communicate on, whatever, and we can secure it. So there's a lot more flexibility in access lists, but with flexibility comes complexity. Security groups are very easy. Access lists take a little more thought. There's the security of Direct Connect. This is actually a whole nother service in Amazon. I think I mentioned this earlier in the series, where you've got all of these Amazon availability zones, right? So AZ1, AZ2, all in this region. Well, there are some regions that support a service called Direct Connect, which is where Amazon has partnered with another data center, owned by somebody other than Amazon, to allow you and I to walk in their door and install our own equipment, and they will actually allow you to speak directly into the availability zone bubble. So you have fiber optic high-speed connectivity. So maybe there's a device that you have. I'll just say like a NAS, a network attached storage, a box that has 50 terabytes of storage, which would typically cost you quite a bit if you wanted to use Amazon's services for 50 terabytes of storage, but maybe a NAS just costs you a few $1,000s. So you can go to this little Direct Connect facility. Of course, you'll pay them for space in there, just like a normal data center, and install your NAS device in there, and now it's got gigabit plus speed access into the availability zone, so you can run your backups and whatever else, transfer data into there. So actually, you know what? Something I didn't even put on here. It just occurred to me. There's a service called, I guess it's not really security worthy, but now that I've opened the can of worms, I've got to mention it. It's called import/export. So for instance, let's say there's a ton of data that you have up here that you don't want to copy across the internet. You don't want to pay for that bandwidth, or it's just maybe too much. Maybe it is that 50 terabytes of data that you just don't want to copy out. You can actually flag Amazon to say, hey, I'm going to send you a drive. Maybe it's this little NAS drive or a USB drive or whatever you want. They tell you what's acceptable into there, and they can securely import. So you can send data to them. Maybe you'd send that 50 terabytes of pictures, and you want those put into an S3 storage bucket in Amazon. They can import it for you, or they can even export it and ship it back to you. So I don't know if it I guess you could say it falls under security, but that is a service that they offer. They offer VPN access. So let's say you've got your cloud of devices that you're running inside of availability zone, 50 different servers. You can set up an encrypted VPN tunnel back to your corporate office. So you've got your networking equipment there. Let's just say it's a Cisco router. I can set up my Cisco router to VPN into the cloud. So essentially you have direct access to your environment at AWS. They even have a security gateway where they set up to where it can run backups and things like that from your data here at the corporate site into the Amazon Web Service Cloud, and act as a disaster recovery should something happen here. It can actually back up Amazon services down to your corporate site. So again, more security to it. And let's say you're still kind of creeped out. The fact that you're running on a server and you don't know who else is running on there, or maybe you just want to know that you have kind of a guarantee. You know that nobody's ever going to run on that server. And you'll hear Amazon talk about it as like a noisy neighbor. Like somebody starts going berserk and really jeopardizing the performance of that server, which is something we have to think about. And we'll talk more about that later on. You might say, I don't want that risk. Well, Amazon allows you to buy your own. Now you can't go put your own server in there, but you can actually, we'll call it lease, right? Kind of a lease to own offer, but a lease to where you can lease a full physical server in the Amazon data center that you say, it's my server. No other instances will run on that physical server other than me, which eliminates the risk of somebody being a noisy neighbor that jeopardizes that server's performance. Last thing I want to talk about is a tool that Amazon gives you called Identity and Access Management, more frequently called IAM. What IAM is your user and service management for Amazon Web Services. So when you sign up, whatever account you initially create your AWS account, essentially the guy with the credit card, becomes the master account. If you're familiar with Linux, you can think of it as the root account, as in it has access to everything, including even all the billing information that is on AWS. Amazon says usually once you create that account, you should not use it unless there's a specific reason why you need that master level access. Maybe you do need to change your billing information or access previous invoices and all that. Instead, you should start creating sub-accounts in IAM. Now, okay, where's IAM? Well, if you come to Amazon Web Services, this is the home page of after you log in. IAM is right here. You can see Secure AWS Access Control. And when you come in here, you can see you've got traditional type security where you create your groups, assign what resources those groups have access to, create your users inside of there and assign the users to the groups. And so again, it's very traditional security, but this allows you to dictate which one of these services over here that people have access to, and even oftentimes what subservices they have access to. So maybe, for instance, S3, that's your buckets of storage. That's essentially limitless storage inside of the cloud. I can go in and say, well, I've got all these different buckets right here, and I'm going to say that one user has, for instance, access to this temp bucket CBT. Others have access to this images.chara.org bucket that I have in place. So we've got all of these different buckets, and I can say which users have access to that through IAM. So dictates access to AWS resources. Now, one of the things that's nice is multi-factor authentication is really easily supported. So what do you mean, Jeremy? That means when I sign into AWS, I might have a username and a password, but I mean, if you think about it, that can give you keys to the kingdom, as in the entire data center and every server that's running there. So you might want to add MFA, multi-factor authentication, where maybe you have like a key fob. Where if you've ever seen those keychains that generate a secret code that change once every 30 seconds or once every minute, or even on your smartphone, there's something called Google Authenticator, which a lot of people are using. They have it for Android and iPhone. It's free. You install it there, and you can link it to your account. So when you sign in, you have username, password, and then you go on your iPhone or your Android, and you say, okay, what's my secret number code for this 30 seconds? And it goes, there it is. Type it in, or this 60 seconds, and every 60 seconds constantly rotating. Normally, this is just one example, but normally you have to implement a whole lot of stuff to do multi-factor authentication. Like if you wanted to do that for your environment, it's an expense, whereas Amazon's like, hey, piece of cake, do it for free, set it up in 2 minutes or less. I mean, it's crazy easy to set up. API access through Access ID/secret key. What does that mean? That means IAM controls API, which stands for Application Programming Interface. This allows applications to gain permissions to AWS resources through access IDs and secret keys. So for example, if you've got server A over here where somebody has authenticated to log in, and it needs, maybe you've got users out here uploading pictures. That's my constant example, right? They want to upload a picture to your service. Well, that server may need access to the picture storage, right? So it can do that through an access ID/secret key. It's kind of these long strings that you would provide to your application to do that. And IAM even makes it easier because you can assign roles. I don't know if you saw it in this console right here. Let me get back to it. But IAM allows you to define roles which dictate certain services that a server can have access to. I'm trying to think the best way to say that. So you might say, well, this server has access to the picture drop, so that way you don't even have to worry about this access ID and secret key and changing it and rotating it. It's all done for you in an automated way so that when somebody accesses this, it automatically, securely grants that server access to store stuff in the picture drop. Again, I feel like there's so much more I could say on each one of these, but again, at this overview level, let me just keep it at that. And actually, that's what I was just talking about. Authentication to your applications handled internally. So you can use IAM to grant access to AWS resources. That's kind of through this API. But you also can have your own internal security, right? I mean, you're setting up servers. You've got that foundation AWS gives you, and you're setting up servers on top of there to where you can have your own user accounts, store them into a database, and within your own system, allow access to the application itself. AWS has no visibility to the stuff that's running on your server. Right? And now they have an API to where the application can tie into AWS and say, well, I'm integrating my applications with the services AWS provides, but you will have your own username and password database that you manage, and you can grant access to whatever resources in your applications by yourself. That's where we get back to that shared responsibility model. AWS is maintaining their user accounts and their groups and their roles, and you can provision those. You are responsible for maintaining usernames and passwords into all of your data that you're hosting on whatever services you've decided to run in Amazon Web Services. So, big picture overview, right? But that gives you an idea of, now that we're moving everything to the cloud, now that we're in this big shared environment, can I feel warm and fuzzy about putting my stuff there? Yes, kind of. I'm like, I don't know, because of this. I'm not saying because I'm nervous about Amazon. I will tell you, after working with AWS for a long time, I can tell you they are dialed in on security. They know what they're doing. You don't get those accreditations that they have just by falling into them. I mean, you really have to prove that you have a secure environment. The reason I'm saying, can you feel warm and fuzzy? Well, it's because you're spinning up servers that have all kinds of vulnerabilities in them, and those are your servers. They're my servers. They're our responsibility to make sure that they're secure. So that is my only hesitation. So with that being said, we have seen what AWS does in terms of security and our responsibility in that. I hope this has been informative for you, and I'd like to thank you for viewing.